In Lake Michigan.
Lake Michigan.
Lake Michigan.
Imagine finding something that's been lost for more than a century and finding it in almost perfect condition. That's what happened to someone recently on Lake Michigan.
Beneath the blue expanse of Lake Michigan, stretching out like a silken sheet under the sun, something ancient is stirring. For generations, the American Midwest has basked in the myth of geological safety. The Great Lakes, serene and immense, separate bustling cities and endless farmland. No volcanoes, no major earthquakes, no looming threats. At least, that's what we thought. Ask most people to name the United States' greatest geologic risk, and one word rises like steam from a famous geyser: Yellowstone. The lush meadows and boiling pools. The supervolcano whose 3 eruptions have stamped Earth's memory for over 2 million years. It grabs headlines. It stirs the imagination. Recently, a swarm of earthquakes there has sent ripples of unease through the scientific community. Dozens of quakes, some creeping up to a magnitude of 1.8. Wildfires flicker in the high meadows, and some areas are closed as a precaution, as if nature is quietly rehearsing an old and terrible play. Yet geologists, vigilant as always, assure us there will be no eruption in our lifetime. There's simply not enough molten rock pooled close to the surface, they say, to trigger the kind of devastation that haunts our collective fears. But while the eyes of the nation linger on Yellowstone's hissing pools, an unexpected signal calls attention to the tranquil lakes of the Midwest. There, beneath the still depths and sunken shipwrecks, lies geology just as complex, a reminder that no region is set apart from the restless dynamics of the planet. Recent geoscientific investigation has brought renewed interest to structures deep beneath Lake Michigan, not active seismic faults in the same league as those on the West Coast or under Yellowstone, but vestiges of a dramatic tectonic past. What could be hiding in the quiet heart of the continent undetected for so long? Could the next great geological story unfold not in Yellowstone's shadow, but in the tranquil heart of the Great Lakes? The Hidden Rift, discovery amid still waters. Interest in Lake Michigan's subsurface isn't new, but only with the deployment of sensitive seismometers and advanced imaging has our understanding advanced. Researchers monitor faint tremors and subtle movements, most tied to the deep geologic story of the region. While nearby, more active fault systems like the New Madrid seismic zone have made their presence known. Lake Michigan has, for the most part, remained geologically quiet in historical times. Still, the land beneath the lake is anything but simple. The last few years brought refined seismic sensors onto the lakebed, initially to study sediment drifts and monitor ecological health. Occasionally, a handful of low-frequency rumbles were detected, easily attributed to distant earthquakes, glacial rebound, or the subtle shifts of old sediments. But as these sensors painted a sharper picture, scientists noted minor anomalies in several locations, patterned fractures in subsurface rock, very small, microseismic events, nothing like an earthquake swarm, but distinct enough to warrant further study. The most recent imaging reveals a complex architecture of faults and wrinkles, reminders of tectonic forces that once tried to pull this region apart. These subtle cracks and faults connect the deep, ancient mid-continent rift, a dramatic, failed rift that almost split North America more than 1 billion years ago, with smaller fractures created by the passage and retreat of Ice Age glaciers. No new, highly active fault has been discovered in 2025 that threatens sudden disaster. Instead, all recent indications are that Lake Michigan remains stable, its minor seismic readings consistent with the quiet shifting and settling of Earth's crust. Yet these technical findings dispel the myth that the Midwest is a solid, undisturbed platform. The land and the lake still flexes, ever so slowly. What these silent stories tell us is simple. Geological peace is more relative than absolute. Does this mean a major earthquake is imminent beneath Lake Michigan? Number: the monitoring to date offers no evidence of growing seismic risk, but it does show the value of watching even our calmest landscapes closely. Unraveling the ancient past, glacial memories, and tectonic whispers. To understand any seismic anomaly beneath Lake Michigan, scientists travel backward in time, peeling back layers written in stone and silt. 15,000 years ago, mile-thick glaciers scraped the land clean, carving the basins that today hold so much fresh water. These ice sheets ground down mountains, sculpted moraines, and pressed the crust into a slow, ancient tremor that persists long after the ice receded. But the story stretches deeper, hundreds of millions of years back, when the region now called Michigan was cleaved by the mid-continent rift system. Running from what is now Lake Superior toward Kansas, this rift was once active enough that it threatened to split the heart of the continent. The wound eventually healed, leaving behind volcanic rocks and zones of weakness that echo through geological time. For centuries, these ancient vulnerabilities slumbered, buried beneath miles of sediment and cold freshwater. Today, geologists believe any minor cracks or subtle faults in bedrock could either be ancient features from a failed rift or slight adjustments caused by the ongoing rebound of the Earth's crust, a process that began when the glaciers vanished. As the massive weight of ice melted away, the land began to rise, creaking back toward equilibrium, a relentless process known as isostatic adjustment. According to modern measurements, the crust across the inland Midwest is rising by several millimeters every year. So slowly, we don't notice, yet relentless as the tick of a clock. Could these gentle upward shifts eventually concentrate enough strain to reactivate old faults? Most studies suggest such strain is released gradually through minor movement and settling, producing either exceedingly small tremors or slow shifts. The risk of a major seismic event remains extremely low, but the findings reinforce an important lesson. Ancient tectonic wounds may never be fully healed. What secrets might still be locked within these depths, and what could happen if they ever awoke on a larger scale? This is a question for generations of geologists, not a present threat. Comparisons and contrasts, the shadow of Yellowstone. For decades, Yellowstone has embodied the archetype of geological threat, the restless supervolcano, the simmering caldera, the constant, closely watched drama of magma, sulfur, and rumbling earth. Its history is written in ash layers so deep they shape entire valleys and forests, a memory of past eruptions on a scale that dwarfs human history. And recently, that threat has felt more present than ever. Swarms of earthquakes, 46 located in April 2025 alone, with the largest at M1.8, and hikers forced to flee areas briefly closed by wildfires have kept the park in the headlines. Each unsettling sign is met by the steady refrain of scientific consensus. There are no indications of an impending eruption. Experts who scrutinize the influx of earthquakes and thermal phenomena stress that these fluctuations are normal for such a geologically alive place. Indeed, a new study suggests that there's not enough molten material pooled in one place to trigger the sort of catastrophic eruption that would threaten communities in our lifetime. In contrast, the Great Lakes region, especially beneath Lake Michigan, does not experience the bustling seismic activity that defines Yellowstone. Its story is primarily one of slow change and hidden tectonic history, shaped by an ancient rift and a long glacial past. Small tremors and microfractures are not signs of an awakening threat, but reminders that even calm places rearrange themselves at a pace too slow to feel. While both regions capture our imagination, the differences are foundational. Yellowstone's risks are rooted in deep, rising magma and hydrothermal energy. The Great Lakes faults are ancient, cold scars, slowly adjusting to the loss of glacial weight. One is watched for explosive potential, the other for glimpses of forgotten cataclysms. Danger in the Midwest comes not in the form of volcanoes or legendary quakes, but in the delicate balances sustaining water supply, ecological health, and infrastructure across a vast, interdependent landscape. Implications for the Midwest: rethinking safety. For generations, the Midwest has been celebrated as a refuge from disaster, the land of wide skies, fertile fields, and lakes that seem eternal in their calm. Tornadoes march across the plains, yes, but the ground is steady, the water clean and rich with life. The prospect of high-magnitude earthquakes felt remote, something that happened far away, along the ragged coastlines of California or the volatile stretches of Alaska. And volcanoes, the stuff of textbooks and distant documentaries. Yet every new technical report from Lake Michigan underscores an important reality. Stability is not a guarantee. The land here is not as dynamically hazardous as the West, but nor is it immune to change. Even minor seismic and geologic shifts can carry implications. The real threat to the region isn't the sudden opening of a rift, but the risks facing the Great Lakes as critical resources. Funding freezes, political interference, and the specter of ecosystem collapse have drawn recent warnings from advocacy groups. Water treatment networks, aging and overburdened, have trouble keeping up. Fish populations, battered by invasive species and chemical pollution, are shrinking. A significant earthquake beneath Lake Michigan is exceedingly unlikely based on all current evidence. But what if slow movements or unexpected events ever did disturb sediment layers? Could this affect drinking water quality? Advocates point out that even minor gas emissions, changes in lake stratification, or sediment disruption can influence water chemistry and the fragile balance sustaining millions. Communities have begun to plan for scenarios previously unimagined, not because of an imminent seismic crisis, but in recognition that all crucial resources require vigilance. Updating water infrastructure, improving emergency response, and maintaining ecological monitoring systems are the tools of true preparedness. Environmental tensions, the balance shifts. As scientists trace subtle shifts beneath Lake Michigan, they are forced to confront a broader web of consequences, some geological, many ecological, all intertwined. In recent years, sustained funding cuts and legislative gridlock have undermined the very systems designed to protect the Great Lakes. Water treatment networks are challenged by both aging equipment and new contaminants. Fisheries, once seemingly inexhaustible, now edge closer to collapse from industrial runoff and invasive species. These strains form the true background for any geological concern. Even in the absence of disaster, the region's environmental resilience is growing more fragile. Methane leaks from lake beds elsewhere in the world have raised alarms, but in Lake Michigan, no dangerous increases or explosive events have been recorded. Still, if any geological process, however minor, disturbed the lake's chemistry, the downstream effects could be significant. The Midwest's water security is a silent pillar beneath the nation's food supply and manufacturing. Interruption of that stability, whether by slow-moving geology or by neglect, could impact millions. As history shows, ecological stresses and infrastructure failures often combine in unexpected ways. For now, these are warning signals, not alarms. Reminders that even quiet regions deserve our attention. Monitoring the unknown, a race against silence. Ongoing study of Lake Michigan's geology has transformed the region from an unquestioned symbol of calm into a frontier of scientific curiosity. The USGS and local agencies work to map, in real time, the shifting underworld of a region long considered inert. Highly sensitive seismometers, sonar imaging, and satellite-linked GPS have defined the modern approach to monitoring. Networks on land and, increasingly, along the lakebed collect gigabytes of data, searching for patterns, registering even the faintest tremors. Most data are reassuring. Seismicity remains low, and minor methane emissions, where observed, fall within normal bounds. Yet, each bit of data reinforces this fact. Complacency is not an option. Changing infrastructure, declining water quality, and subtle environmental stressors could interact with even gentle geological change. Scientific teams continue to study sediment shifts, track the slow rebound of the land post-glaciation, and model the rare but not impossible risks of larger seismic adjustment. In the rooms where disaster simulations are run, new questions are asked, not about the next great earthquake, but about resilience. How do societies maintain water security? How will agencies respond when warning systems detect subtle changes, not cataclysmic events? The answers will not come easily, but the drive to ask, measure, and prepare represents a new era of awareness throughout the Midwest. Lessons from Earth's oldest stories. Lake Michigan's geological narrative is less a thriller and more a slow-motion epic, stretching across unimaginable time. Ancient rifts, glacier-scraped basins, long periods of equilibrium, punctuated by rare, unpredictable moments of upheaval. Consider the story of the New Madrid seismic zone, far to the south. In 1811 and 1812, a series of immense earthquakes shook the Mississippi River, reshaping the landscape and surprising a young nation utterly unprepared for seismic disaster. This historic sequence is a reminder: the heart of North America is not immutable. Earthquakes, much larger than any seen recently, are within the continent's memory, though their recurrence is spaced by centuries or millennia. Elsewhere, the legacy of other tectonic features shows up in buried faults, quietly accumulating small adjustments. The lesson is echoed from the Pacific Northwest, where ghost forests and wetland layers reveal past cataclysms. The landscape that seems quiet today can tell a much different story if viewed through the right lens. Here, beneath the glass-cold water of Lake Michigan, that ancient story continues, written now as a patient adjustment instead of a sudden drama. The lesson is not one of looming threat, but of humility before the slow, unceasing motion of our planet. The past is present beneath our feet, making its presence known most often in the subtlest ways. The uncertain future, possibilities, and preparedness. So what does it mean for America? Indeed, for the world, if the Midwest is not as impervious as legend suggests? What lessons should policymakers, city leaders, and ordinary citizens draw from the ever-evolving knowledge beneath our feet? Start with the basics. Seismic risks exist even in stable-seeming regions, but the overwhelming threat to the upper Midwest remains environmental, not tectonic. Water quality, infrastructure, and ecological resilience deserve vigilance. The worst-case tectonic outcomes for Lake Michigan are improbable, given all current evidence, but continued observation is warranted. The best-case outcome? The region continues to experience slow crustal rebound and minor seismic adjustments, but no damaging events. The water remains clean, the lake serene, and the structures along the shoreline stand strong. Research protects both resource and reputation. Scientists refine their sensors, infrastructure gets gradual upgrades, and vigilance becomes part of regional culture. Should a darker scenario ever unfold, with unexpected collapse or sediment disruption, the impact would manifest more in water treatment challenges and ecosystem responses than in architectural collapse or mass disaster. The need remains. Prepare for the full range of possibilities, however remote. Cities, some already revisiting their building codes and disaster plans, proceed thoughtfully. Investments in strong infrastructure, redundancy in water management, and transparent risk assessment are never wasted. The greatest uncertainty may be the pace at which geological and ecological threats unfold, and our readiness to adapt. New questions in the age of discovery. What then should we make of these geological signals beneath Lake Michigan? A landscape vast, old, and restless within its own slow time frame. Scientists emphasize that this is not a crisis, but a beginning. Our knowledge continues to expand. The full complexity of Great Lake geology remains to be explored, though no evidence justifies existential fear. Small earthquakes are almost always the gentle creak of a planet settling, not the prologue to catastrophe. Minor methane leaks are natural, not harbingers of explosive forces. But these findings prompt a new respect for the never-ending process that shapes our world. Government agencies tune their monitoring systems, add seismic preparedness to their routine, and advocate for resilient water and environmental policies. The myth of an unshakable Midwest gives way, quietly, inevitably, to an understanding rooted in science. From the orchards of Michigan to Chicago's urban shores, communities recognize that safety is built as much on preparation as on tradition. The next question. This is not the story many expected in 2025. For decades, American anxiety focused on the drama playing out over Yellowstone, a supervolcano with swarms of earthquakes and a magnetic hold over our imagination. But in that certainty, we nearly overlooked a truth that every landscape holds its silent vulnerabilities. Maybe the greater danger isn't the ground shaking violently enough to destroy cities, but the subtle drift of science and nature gently challenging the stories we tell ourselves about safety and permanence. For now, the sun rises over the Great Lakes, the water gleaming as if nothing is amiss. But below, in the depths and the cold, the land adjusts, faults rest, sediments settle, methane breathes through the ancient wrinkles of a billion-year past. Each new discovery is a whisper, not a shout, a reminder that the Earth's stories are never truly finished. Will the next chapter in America's geological history be written in ash and fire from Yellowstone, or in the quiet, persistent shifts beneath Lake Michigan? Stay curious, stay aware, ask questions, especially of the places that seem the most peaceful, the most unchanging, the most safe. If this year has shown us anything, it is that the Earth is never finished with its stories. Like this video, if you want to follow every twist and tremor beneath the heart of America. Subscribe to never miss a new discovery. And in the comments, tell us, do you think the Midwest is ready for its new role as a geological frontier? Or have we only begun a quieter story? One where the most important changes creep in, slowly beneath the surface. Thanks for watching, and remember, in the silence under every lake, in the stone beneath our cities, the Earth keeps its secrets, waiting for their moment to rise.